All right, so today the plan was doing binomial, but after looking into the curriculum, I realized that there's not much practice questions to be done on binomial from the textbook, at least. Or maybe I haven't found the questions. Hannah, I was just wondering, because we did the binomial chapter, right? And then which chapter does that belong to? Do you know?
Isn't it just arithmetic sequences?
Arithmetic? Okay, interesting. Let's see if I can find it there. Oh, okay, nice. Okay, it's actually there. I was looking at the probability. I was like, oh, it's not even there. All right, in that case, everything's much easier. All right, cool. Oh, that's really good then. That is really good. All right, that's good. That's good. All right, so yeah. Oh, okay. So I was gonna prepare the question material, but it turns out I didn't find it. But now I don't think I have time for it, so I'm just gonna go to the textbook later. Uh, but right now, before we get to the practice questions, okay, Hannah, I think this will be more like a revision for you, and for everyone else, this might be new. Okay. So before we get to the questions, let me just introduce you guys the what is binomial. By the way, is my mic okay? Is it really clear?
Yeah.
Okay, cool. All right. Ryan and Adriana, are you guys here?
Yeah.
Yeah.
Okay, sweet. Binomial. What is binomial? I don't know how to translate this. Binomial. Bi means two. Okay, bi is like this. It means two. Nomial. You might know the word polynomial. Why is my what? My writing pad is so laggy. I can't even write fast. I gotta write slow. I don't know why. This is very weird. Yeah, I can't write fast. This is so weird. Why is this broken? Maybe try another USB plug. Nope, it's just this computer, I guess. And anyway, bi means two. Nomial, you guys might think about the word polynomial. Okay? Uh, when you say nomial, you think about polynomial. Quadratics. Polynomial. What is polynomial? Does anyone know what is polynomial? No? Okay. So we know quadratics is one type of polynomial. Okay? It's a degree 2 polynomial. Okay? Oh my God, this pen is driving me crazy. See, I'm trying to write a Q and it's like not writing it properly. I can't even write fast now. Just gotta go slow so the board can pick it up. This is so weird. So quadratics is one type of polynomial. It's what we call a degree 2 polynomial. Okay? So in general, a polynomial is something like this. We got a times x to the power of n plus b times x to the power of n minus 1 plus dot 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 dot. So you get a coefficient and an x power term. This is called a polynomial, okay? And quadratics is called a degree 2 polynomial. So it only goes up to x squared degree 2. Okay, any questions? And binomial, I guess you can't really directly translate it into something, but it pretty much means a certain combination, okay? Certain set of numbers and the certain combinations. Binomial, what does the binomial theorem say? Wait, let's see. Let's look at the textbook for the theorem. I don't even know if just a thing of binomial theorem. It's just a thing that we learn, you know? Yeah, it doesn't really say. Oh, binomial theorem is a formula. Okay. So what is binomial? Binomial counts the number of combinations in the quadratics or like polynomial expansion. For example, can anyone tell me how to expand this?
A squared plus 2ab plus b squared.
Okay, a squared plus 2ab plus b squared. Oh my God, I'm so tired of this thing lagging. Do you guys see how my writing is like not working out? It's like normally it's picking up my pad at a higher rate, but right now today it's just not picking it up properly. Let me see if I can. Let me see what the problem is. It might be, I don't know if it's the pen. I think it's Zoom. I think Zoom is lagging. Okay, let's see if I can. If I use this whiteboard, is it better? Oh, this is better. Okay, then we should use this whiteboard. Okay. Yeah, sorry, but we don't get. Okay, this is much better. Okay, so first of all, we can expand a plus b squared. This is a squared plus 2ab plus b squared, okay? And now we are interested in what about a plus b cubed? Does anyone know? Or does anyone know how to work this out? I think everyone I think everyone knows how to work it out. So what you want to do is you want to kind of expand it like this. And you know this is 3 bracket multiplying, and this is what we had previously, right? Ryan, were you gonna say something or not?
Wait, say what?
I saw you turn your mic on and off. I thought you were gonna say something.
Oh no, I forgot to turn my mic off. That's why.
Yeah, so we expand it like this, right? Into 2 brackets, and each bracket have a sum inside. And now we just do the classical way of the first term multiplying the second term, the second one, and then maybe I should do something like this. 1, 1, 2, 3, and then 1, 2, 3. So there's going to be 6 terms, right? Okay. I believe this makes sense. So everyone, please try to work this out and then send me the answer. Okay. I think I'll give you guys like 2-3 minutes. Hey, I'm getting an answer. You forgot something. Okay. Ryan, you sent it to everyone, but I don't think anyone else gonna copy you.
My bad.
You can unsend it, but like, yeah, guys, just try to work it out first and see if see what you get. Okay. In the meantime, be right back. Oh, by the way, guys, I'm back in Auckland for a while, so if any of you want to do one-on-one lessons, I can do it offline as well. Ryan, that is correct, by the way. Yeah, Ryan, probably unsend it so everyone else can have a try.
Oh yeah.
Yeah. Adriana, correct. Hannah, how are you doing?
Shit, Michael, did you get that? Like the
Yeah,
emergency?
I did. Hannah, did you get it?
Yeah, I'm just typing it out.
No, I was talking about the national alert.
Oh yeah.
Adriana didn't, because Adriana is in Sydney. Bro, I saw something. It's like alien invasion or something.
Yo, that'd be actually crazy.
Okay. Hannah, you are missing something. But it's okay. Look at what I do and see which part you missed, okay? So the first term is of course a cubed, right? And then you have, let's do the top ones first, and then you have 2ab times a, which is 2a squared b, right? And you got b squared times a, which is ab squared. And for the bottom ones, you have a squared b. You have 2ab times b, which is 2ab squared. And you have b cubed. Hannah, is that what you got, or are you missing something?
Yeah, that's what I got.
Okay, in that case, wait, in that case, okay, I don't know why you, okay, then you simplified it wrong. So this is the term on itself. A cubed cannot be combined with any other term. But if you look at the a squared b term, a squared b, there are three of them, right? There's 2a squared b and a squared b here, so it's 3a squared b. Does that make sense? It's fine if you say no. If you say no, I'm just gonna explain it in more detail.
Yeah.
So does it make sense?
Mm-hmm.
Okay, and then you have ab squared. So this is 2ab squared. Okay, and lastly you have b squared, b cubed. So yeah, the factorization is although it's just variables, I guess it's not as intuitive. You could think about it like this. If you have 2a squared b plus a squared b, this is like 2 times a squared b plus 1 times a squared b, right? And then you look at your basic factorizing thing, how many a squared b's you have, right? So this is 3 times a squared b. Okay? We just ignore the multiply sign because we get so used to it. Okay? And it turns out it's this kind of thing. All right, guys, let's just do one more practice. Just do one more practice.
Wait, Michael.
Yeah?
I need to go to the toilet. I'll be right back though.
Okay, yeah, it's fine. Yeah. Okay, the problem is with this thing, I can't really. Oh my God. Do you guys just see what happened? I can't really like zoom out a lot because this whiteboard is the old whiteboard. All right. Lastly, we're just gonna do this: a plus b to the power 4. Okay, and we use the same thing. We use the above. So we use this. We use a plus b times a plus b cubed times a plus b. And this we already know is what we're having above, right? A cubed plus 3a squared b plus 2ab squared plus b cubed. Okay, and a plus b times a plus b. Okay, this is the last one we're gonna try. Last one we're gonna try. And oh, sorry, guys. I don't know if you guys picked up this mistake here. This mistake here. There should be 3. I forgot to put a 3 here. Did you guys pick it up?
Yeah.
Yeah. Just tell me next time, okay? Sometimes I make mistakes, and it's bad for what is it called? It's bad for memorization or like habit as well if I make a mistake. So if you see anything strange, just tell me. If it's my bad, I'll fix it. If it's you're understanding something wrong, I'll tell you what you understood wrong so you can learn as well. Okay? Yeah, so interrupt me if there's any mistakes. I was like, yeah, this is not good. All right, this should be fine. Okay, now guys, do this expansion and see what you get for a plus b to the power 4, okay? Yeah, do it and send it to me in chat. I will be right back. I'll go bathroom as well. And when Ryan is back, well, I'll just tell him to do this. Okay, I'll be back 3 minutes. All right, guys, I'm back. How are you guys doing? Hello?
Oh, I'm still writing it down.
Okay, okay. It's just that I gotta do. I don't know if you guys know it. It's called colonoscopy. Colonoscopy. And I gotta drink a lot of liquid and go to the bathroom to so my inside is clear. Yeah, so it's just that I gotta go to the bathroom a lot. Ryan, are you back? Okay, he's not back. Hannah, are you back? Oh, Hannah's gone as well. Interesting. Where's Hannah?
Sorry, I went to the bathroom.
Oh, okay, yeah, all good. Did you finish?
I think so.
Okay, well, send it to me in the chat. What did you get? All right, let's see. All right, Adriana. Okay, Hannah. Oh, okay. Adriana, your third term is wrong. And your third term and your last term is wrong. The first three term are correct. Okay? Adriana, check your third and last term.
Oh, I accidentally. Oh, okay. I'll rewrite it.
Hannah, your first term is oh, how did you get A4B? If it's A4, then it's just A4. You can't get a B. All right, you get A4 from, okay, Hannah, listen up to this.
Oh wait, I did it. Oh wait, never mind.
You get A3 times A, right? That's
No,
A4.
I know how to do it now.
Okay, okay, all good. Yeah, no rush, no rush. This is as I said, this lesson is more for practice rather than learning new stuff. I get how this is new stuff, but the focus will be on practice. Okay?
I'm back.
Okay, do this expansion. Guys, I think in the upcoming terms or like in the upcoming lessons, I'm gonna let you guys like kind of vote or like decide on what we want to do, what topics. Because it kind of helps if we do topics that your school's gonna do as well. So tell me anytime, like you can feel free to just interrupt me anytime during the lesson if you want to do a specific topic or like yeah, if it's not relevant, I might just arrange it the next week. But if you have something that you need to work on in school, we can bring it to the lesson if it's relevant for everyone else. Okay? I think this is like most relevant for Hannah because he's doing the exact same course. And for Adriana, you'll be doing this next year. And for Ryan, you'll be do. Wait, Ryan, what course are you gonna do?
I'm pretty sure I'm going to do Cambridge.
Okay, yeah, then it's pretty much similar stuff, but different curriculum. Because math is like the same across everything. All right, let's see. Oh, Hannah. I think you got a typo in the first term. And everything else looks fine. I think you got a typo, but everything else looks fine.
Yeah, I think I meant 4.
Yeah, Adriana, that's correct. Nice. Okay. Ryan, we are waiting for you now.
Yo, I just got back. Give me some time.
Okay, I'll give you like 2 minutes. All right, in the meantime, I'm gonna write up the second line, and Adriana and Hannah, you guys can check against your answers. But I believe both of you got it right.
Wait, Michael, I'm almost done.
Okay?
Let me type it in before you type the answer.
Okay.
Oh wait. Well, next time I'll just send it to you first. Okay. I sent it in the chat.
Okay, let's see if it's correct. Oh, okay, one term is wrong. Your second term is wrong. Every other term is correct.
Second term.
Yes, your second term is wrong.
Oh wait, no, that's a typo.
Okay, that's fine then. So the key here is that, okay, if you think, before I explain that, I'm just gonna go through the answer first, okay? So there's nothing different. It's just a lot of algebra, right? But in the end of this lesson, when I give you guys something like a plus b to the power of 6, you guys gonna get it instantly, okay? That's the goal of the day. This is the power of binomial, okay? But before we get to there, we're just gonna start from the basics, okay? Oh, by the way, guys, make sure to keep everything on paper. So if you need a reference, if you have to reference back, you can look at it anytime. That's the first 4 terms, and then we got a cube b plus 3a squared b squared plus a 3ab cubed plus b4. Okay, so I just did the hardcore expansion, and let's see. A cube b, there are 4 of them, right? And then we got a squared b squared, a squared b squared. There's 6 of them. And we have ab cubed. AB cubed, there's 4 of them. It makes sense because if you think about it, it have to be symmetric because you got a plus b to the power 4. It kind of makes sense to be symmetric because a plus b to the power 4, this actually is the same as b plus a to the power 4, right? So if you have, let's say, if you have 3a squared b, then you're probably gonna have 3ab squared because it have to be symmetric, right? Because you can swap the order of a and b. So a and b are interchangeable, right? So you got the a cube, you got a b cube. Does that make sense to everyone?
Yeah.
So in this case, when you bring everything together, you got a 4 and then you got 4a squared b, but you also got a cubed b, but you also got 4ab cubed. And you have 6a squared b squared. There's nothing symmetrical about this because the power of a and b are already the same. And then you got a to the power 4. That means you got b to the power 4 as well. So yeah, symmetry here is very intuitive because you can swap the order of a and b. And apart from that, there's something that's very interesting here. That's what I was going to talk about. That's what I was going to talk about earlier. So you know how we're technically doing a power expansion, which is something like this: a plus b times a plus b times a plus b times a plus b, right? We're technically doing this. So each term each term, there's going to be, each term in the final answer is going to be a product of 4 variables. Does that make sense? So we only have 4 things multiplying each other here. Even if we break up the bracket, the product is going to be a multiplication of 4 variables, right? Let's just pick a term example. Let's pick the first term, a cubed, a to the power 4. That is a times a, that is a times a times a times a, okay? You don't get a 5th term. That's why in the beginning, one of you made a mistake. One of you had this term. I was like, you can't get this because, I think it was Hannah, right? You can't get this because A4 already took up everything. Where did you get a B from? You don't have any more multiplications in the end, right? So all the terms are a product of 4 variables. And here, for example, 4a cubed b. This means a cubed b, but you got 4 of them, okay? And to be more precise, you can get the a cubed b by having b, or a, or a, or you can have b. That's 4 combinations of a cubed b. Does that make sense to any of you? I don't expect this to make complete sense because there's a lot of information to take in. But does that make sense? Does that kind of make sense? Like 50% or like 70%? Anyone?
Mm-hmm. Yeah.
Okay. So essentially, we kind of combine all the terms, and they are a combination of the things that we multiply together. Okay? That's just a rough idea. It will become more clear in the future. Oh. Okay. So right now I'm gonna summarize everything. Before I summarize, So we got A plus B. Can anyone just tell me what they got for the answer, just to kind of reinforce the memory? Just what did you get for the answer? Anyone?
A squared plus 2ab plus b squared.
Okay. Okay, Hannah, what did you get for this?
A cubed. Wait for the cubed one.
Yep.
A cubed 3 a squared b plus 3 ab squared plus b cubed.
All right, Ryan, what about the last one?
A to the power of 4 plus 4a to the power of 3b plus 4a. Wait, why is it 6, mate?
Did you send me 4?
What?
You sent me 6.
What?
You sent me 6.
Isn't that for a different equation? Oh no, that is my bad, my bad.
What do you mean? Where did you mess up?
Wait, let me expand it again. Hold on. I just gotta like write it all out.
Your answer you gave me straight away was correct. All right, in the meantime, I'm
Yeah.
gonna write the answer. Yeah?
Yeah, I did get 6. Never
Okay.
mind.
6a squared b squared, and then?
Yeah, plus 4a b cubed plus b to the power of 4.
Yep. All right, so that's the answer we got for now, and then we're not gonna go more. That's too no point. All right, before I explain what the formula is, I'm gonna tell you guys something called Pascal triangle. Has anyone heard of this before?
Oh, I have.
Yeah.
I've heard.
Okay. Yeah, Hannah, you definitely know because you did this. All right. So Adriana, do you know what this is?
No.
You start from the tip and you write a 1, and then you write 2 more ones on the side. The ones goes down on the side. And the middle number here, you add up the two ones, becomes a 2, okay? And the ones just keeps going down on the side. And then you add these two up to get a 3, okay? You add these two up to get a 3. And the 1 keeps going down on the side. All right, Adriana, what is the next row?
Huh? Do you add the 3 and the 1?
Yeah, you add it like that.
Oh, like 4, 6, 4.
But you write that 1 as well. So 1, 4, 6, 4, 1, okay?
Oh, that. Oh, okay.
What about the next row?
1, 5, 10, 10, 5, 1.
All right, it is symmetry as well. Of course, it's symmetric because when you start from the beginning, everything is symmetric. There's no reason for it to suddenly go not symmetric, right? It's always symmetric. All right, Ryan, what is the next row?
1. Wait, I can't read it.
Oh, is it blocked?
No, I'm like stuck up.
I don't get what
Like
you
I
mean.
can't go downwards.
Oh, is it outside the screen?
Oh, wait, now I can see it. It's just like when I move my mouse, the pop-up comes up.
Okay. All right.
6
Yeah,
and 15,
yeah,
20, 15, 6, 1.
yeah, symmetric. Okay. Yeah, everyone pretty much get the idea. And if you look at this triangle, you're gonna see something interesting here. You should get a 1 here, right? And a 4, 6, 4, 1. 1, 3, 3, 1. 1, 2, 1. Is that a coincidence? No, it's not a coincidence. It's because the theory behind this is the same. And apart from looking at the coefficient, we also look at the power. So the power are not this is not a random order, okay? We start with the highest power of A and lowest power of B, which is 0, right? B0 is 1. And then we decrease the power of A by 1 every time, okay? And in the meantime, we increase the power by B across every term. Does that make sense to everyone? Hannah and Adriana?
Yeah.
So it is the same for the previous ones. Let's say we can write this out. It's 1A3B0 plus 3A2B1 plus 3A1B2 plus 1B4. Sorry, A0B4. Technically, I should write. But for example, the last term, 1A0B4, we just write B4. The 1 and the A0 is both 1. It has no effect on the B4. Okay? But do you guys understand this pattern? If there's any questions, ask me, but there is an obvious pattern here. Do you guys understand that pattern?
Yeah.
Adriana?
Yeah.
Ryan?
Yo.
All right, so now let's say we are given this sequence here. Let's say we are given this sequence here. I understand it's outside the screen, so let me actually quickly fix it. I'll see if we can fix it. All right, cool. I think it's fixed. All right, now, let's do this row, okay? It's 1, 6, 15, 20, whatever it is, right? This corresponds to A plus B 12, 6, right? Try to, without doing all the working, tell me what the expansion of this is. Using the
1,
pattern we have.
e to the power of 6 plus 6a.
Oh, send it to me in the chat.
Oh,
Yeah. I want everyone to take a practice. Hannah, is this easy for you?
Mm-hmm.
Okay, cool.
Wait, so we just do the same thing that you did for a plus b cubed, like the
Oh, we don't do the classic expansion anymore. We try to use this pattern to generalize.
oh.
Because if we just keep doing the expansion, it's too tedious. But with this pattern, right? Do you see this pattern here, Adriana?
Yeah.
If we apply this pattern straight away, we can get the answer. Okay?
Oh, okay.
Yes. All right, Hannah. Ooh. That is very good. I think that is correct. Yeah, me and Hannah have went through this topic in a few classes before. So I guess it's good revision for you as well, since your exam is 2 years away and you're not going to do any more revision on this until then. Doing something binomial now, I think it's a good revision.
Michael, for the powers,
Yeah,
does it just go down like 6, 5, 4, 3, 2?
1, 0.
And that's how the powers goes, right?
Yeah, yeah.
But
And
how
the powers have to add up to 7. 6, sorry.
okay. Then how come the last one is a 6 if it goes down 6, 5?
I don't, 1 second. Adriana, you should start at 6. Okay? Because I told you 6, so you should start at A6 and then keep going and see what happens.
Okay.
Yeah. What you did was A plus B4. A plus B4. That was correct for A plus B4, but not 6. All right, sorry, Ryan, what was your question?
Oh, no, mind.
Oh, you got it?
Yeah.
Nice. Oh, Ryan, check your 20 term.
Mm-hmm.
Oh, also check your 15 term. Oh, wait a second. Also check your, okay, check your, all your 15 terms and your 20 terms.
Oh boy. Wait, but I thought you said the powers went down 6, 5, 4, 3, 2.
Yeah, 6, 4, let me see. Okay. Your power of A goes down while your power of B goes up, right?
Mm-hmm.
The power of A is first of all, it's not going down properly. It's a 6, 5, 4, 2, 3, 1.
Ah,
Second of all, your B is not increasing properly. It's 0, 1, 3, 2,
oh,
4, 5.
never mind. Okay, I get what you mean now.
Yeah.
Damn.
All right, Adriana, yeah, we're waiting on Adriana. Let's see. In the meantime, Ryan, I believe this is correct. So, yeah. All right, Adriana, how are you doing? Are you stuck?
No, I'm just typing it out.
Okay, sweet. Ryan, is this new to you or have you kind of done this before?
No, mate, this is like pretty new to me.
Okay. Do you think this is fun or?
I don't know how math becomes fun, but like, it's all
Okay. Adriana, that is correct. Nice. Okay. Then all of you have pretty much got the idea. Yeah, so when you don't use the hardcore way, you look at the coefficient first. you start with 1, 6, 1. You don't have to write anything. It's just a 1, 6. You know what? Since we're doing this since we're just starting to do this, let's write everything properly. 1, 6, 15, 20, and then 15, 6, 1. Okay. And then we start with a to the power of 6, b to the power of 0, and then a to the power of 5, b to the power of 1. Keep decreasing. A4, b2, a3, b3, a2, b4, and then a1, b5, and then a0, b6. So as we can notice, the pattern goes 6, 5, 4, 3, 2, 1, 0, and 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. Okay, and then we can try to simplify this, which is a6, and all the other term is the same. Yeah, all the other term doesn't really need much simplification. But no one really writes this, right? We need to simplify these kind of stuff. This, right? These kind of stuff need to be simplified. 15 a squared b4 plus 6a b5 plus b6. Yeah, that's it. So this is binomial expansion in a nutshell. This thing is called binomial expansion, okay? Does anyone need to copy anything down before I delete this page? It will be in the class note, of course. Okay, cool. So normally I like to explain the theory to you guys first, but in this case, because the theory is actually quite hard, it's to do with combinations. So I'm just gonna explain the logic, like the idea first, before we explain the theory. So using that pattern finding, why can't I make full screen? Using that pattern finding trick, let's do some practice, okay? So in this case, A, B are numbers and characters. Before I let you guys do the practice, just a quick tip here. For example, if we have 4x here, treat this as your A and treat this as your B, okay? You're gonna have something like 4x to the power 4 to begin with. And I want you to simplify that to 256x4, okay? Does that make sense to everyone?
Wait, can you say that again?
Because fundamentally, these kind of stuff are still like a plus b to the power 4, right? This is the same as a plus b to the power 4, with a being 4x and then b being y, right?
Oh yeah.
You're gonna have a4 plus 4a cubed b 1, 4a cubed b plus dot 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 dot. And this a4 is gonna be 4x to the power 4, okay? And I want you to expand these so that it becomes 256x4, okay? So we have one extra step of looking at these two terms. Ryan, does that make sense?
Yeah.
Anna?
Yeah.
Adriana?
Yeah.
Does it really make sense? If it doesn't make sense, fine, you can tell me.
No, it does.
It does? Okay. It's okay. Try to do 1 and 2 first, and then we'll see how we go, okay? And for 2, this is it's the same as A. So A equals 2, and let B equals negative b, okay? I get how this is kind of weird by having a negative b here, but like, yeah, just kind of hardcore substitute 2 and negative b into this. This is very bad math notation, but you guys get what I mean, right? Just substitute negative b instead of b.
Wait, and so we're just meant to treat this like a minus b to the power of 5 for that.
Oh, you
like,
treat this like a plus b to my power
Ah,
5.
A plus
For the b, you put negative b instead. So you get something like this, okay?
so you just substitute. Okay.
I can give you some examples. You get like 2 to the power 5 plus 5 times 2 to the power 4 times negative b to the power of 1. Okay. Plus 10 something to the power of something to the power of 3 something to the power of 2. Right? Plus dot dot dot. Does that make sense? Okay, I made a start for you guys. Do 1 and 2 first and send it to me in the chat. We'll see how we do. And I'll go to the bathroom. Be right back. All right, guys, I'm back. How's everyone doing?
I
Okay. Hannah and Adriana, your one is not wrong, but you have to simplify the terms. For example, for the second term, you have 4x3 times 5, right? You have to simplify it to 20x3. Okay? Does that make sense?
Yeah.
Yeah. So please simplify the first two questions when you have time, okay? If you're doing the second one already, just do it.
wait, Michael, doing Michael,
Yeah.
do we need to do question 3?
Yeah, do question. Wait, let me check your first two questions first. For the first one, let's see if you do it correctly. Yeah, when you get the first two correct, do 3 to 6, but don't have to send me the answer. We can like go through it all together.
Oh, instead of doing 2, I accidentally did 3.
Sorry?
Instead of doing 2, I accidentally did 3.
Oh,
And I'm like in the middle of doing that.
oh, that's fine. You can finish it.
Okay.
I'm just checking Ryan's answer. Oh, this is so hard to check, not gonna lie. Oh,
It's so hard to do, not gonna lie, mate.
it's okay. Doing it is okay.
I'm literally about to crash out, bro.
You sleepy?
No, it's just like it's a lot of writing.
Yep, Ryan, you're correct. Your question 1 is correct. I'm checking question 2 right now. Hannah, by the way, please simplify the numbers. For example, by the way, your question 1 is correct. Adriana, your question 1 is correct as well. But simplify the numbers so that you get x4 and something x3, 20x3 plus something x squared, etc. Does that make sense?
Yeah. Can I just send you the unsimplified version for now? I'm like
You want me to check
typing
this
it
correct or
in.
not?
Yeah.
Yeah, sure. I'm checking Hannah's question too. Hannah, are you simplifying right now?
Yes.
Okay, yeah. Yep, the unsimplified version looks correct for 2 as well. So simplify it and see what you get. Yep, Hannah, that's correct. Oh, Hannah, I believe there might be a typo. But that is correct. Was that a typo?
Where?
Third term, fourth term, 500x cube. You shouldn't have the cube here. It should be 500x.
Oh yeah.
Yeah, because previously you have 4 times x times 5 cubed, right? Adriana, that's correct, I believe. Yep, that's correct. Okay. Yeah, try to simplify it. Okay, give me 1 second. Okay, I can't. Oh, the problem is I can't put the picture onto the old whiteboard.
Wait, Michael, should I still type the answers too?
No, not for 3 and 6. I can't check efficiently.
Thank God, bro, because like there's so
Yeah,
much.
so much
Oh.
typing.
Yes, bro. The working doesn't even fit on my page.
Oh, no, shouldn't be. Shouldn't be. Working should be fine. All right, Hannah, your 1 and 2 are correct. Your expansion for 1 is also correct. Sorry, simplification. So simplify question 2 as well, and then move on to 3. Okay. We're gonna have a break after this. Maybe after 3 and 4, we're gonna have a break. All right, Adriana, you don't have to type to me. Just do 2 and 4, Adriana. And when you guys have done it, I will do it all together. Okay, I'll go through the answers all together, and you guys can see if it's correct or not.
Wait, so do you want me to type it or not?
Just type it for 1 and 2.
Michael, I finished 3 and 4 already.
Oh, do 5 and 6. See, that was fast. Did you simplify?
Yeah, I simplified it. All right.
What's your first term for 3?
3. Oh, 64x to the power of 6.
Second term?
Negative 192x to the power of 5.
Okay, sounds good. Adriana, did you use calculator?
Oh shit.
Yeah. Are we
Ryan,
not supposed
did you
to?
use it, Ryan?
Me?
Yeah.
Yeah, I did use calculator.
Okay,
No, but
try not to use calculator, okay? Because
Oh.
honestly, I don't know for Cambridge, but for IB, these kind of stuff can appear in non-calculator paper.
okay.
So, for example, 2 to the power 6, you gotta know it's 64, or you just
Yeah.
do it enough times so you know it's 64.
Hey Michael, listen. For 1, 2, I didn't need calculator. And 3, I also barely needed calculator. I only needed like a major amount for 4. Actually,
Oh,
not even need a major amount for 4. Like I barely used it, so
I think 4 is fine. 4, the hardest one you're gonna do is 4 to the power 4, and then
yeah. No. It was 3 that I had a little bit of calculator
yeah.
use.
Okay.
It was
Try
chill.
not to use calculator. Like if it's not a ridiculous multiplication, don't use calculator. Okay.
Yeah.
All right. In the meantime, I'm gonna write out my working for 1, which everyone has already got, and 2 is an important one because it has negative signs. Oh man, I hate this lag. Why is it lagging so much? I think it's my computer being too old. Not even joking.
I'm on question 6 now.
Nice, nice. Good job.
I think I'm gonna need calculator for this, bro. I can't lie.
I felt really fast. Don't use calculator. Since you have more time anyway, just do the practice.
Calculator is life, mate. Okay.
Okay.
3
It
to
depends on if you really depends.
3.
All right, for one, I believe everyone's got the correct answer. The important part is 2. Hannah, have you simplified 2 already?
I'm doing it right now.
Okay.
I finished 6. 8.
Sorry, I had to run bathroom again, guys.
Yo, Michael, I finished, by the way.
Oh, nice, nice. Okay, you can take a break, and once you guys finish 3 and 4, we'll take a break, okay?
Oh,
Wait,
we
Mike.
have to go to 6.
Oh, did you do 5 already? If you did 5, it's already fine. It's fine.
Okay, can I have a break now then?
Oh yeah, you did first 4, right?
Yeah.
Okay, Hannah, which one you up to?
4.
Okay, yeah, once you finish 4, you can take a break. Don't worry, I'll make the break long enough for everyone.
Wait, Michael, have you seen the film Talk to Me, like the horror movie?
Nah,
Wow. Wait, well, do you know this piano song or like this piano piece?
is it in the movie? I can barely hear anything, by the way.
Yeah, really?
Yeah, because Zoom doesn't pick up non-human frequency, I believe.
Oh boy. Wait, can you hear the piano now?
Barely.
Oh boy.
I tried to play it before, but it doesn't work. A little bit. Hannah, are you finished?
Almost.
Okay, take your time, no rush. When you finish, we'll like officially start a break, and then we'll explain everything after. Okay? Ooh, Ryan. Your question 2 is wrong, Ryan.
Wait, what did you say?
I said your question 2, I think is wrong.
Oh boy.
So
Oh,
check your question 2. I might be wrong as well, but I think you're wrong.
Oh, I finished, by the way.
Mm-hmm. Cool. All right. Well, we'll have a
no,
break.
I'm wrong.
You're
I'm
wrong?
wrong. Yeah. I think I made a mistake.
We'll be back at 7:22. I'll still be here, but yeah, we'll have a 5-minute break. All right, guys, how we doing? Okay, so does anyone have any questions about the first two answers? Is everyone back?
Yeah.
Ryan? Hannah? Ryan? Hannah? They are not back. Ryan? Hannah, are you guys back?
Yeah.
Okay, Ryan is just gone. Okay, let's start. For the first two questions, do you guys have any questions?
No.
Okay, so answer is consistent, right? Also, oh, Hannah, I forgot to tell you this. So you see you have 80 times negative b. This is just minus 80b, okay?
Mm.
So technically the coefficient is minus 80 and the unknown variable is b, okay? But for the second term, because it's a square, right, the negative sign cancel out. Negative b square, same with the fourth term, negative fifth term, sorry. Negative b to the power of 4, the negative sign cancels out. That's why we have alternating signs, plus, minus, plus, minus, plus, minus, okay? Does that make sense, Hannah?
Yeah.
So when you simplify, you have to add in this step, all right? And, all right, so all right, I'm gonna use the other whiteboard, otherwise it's too laggy. All right, cool. Ryan, are you back? Ryan's still not back.
Yeah, I'm back.
All right.
I'm back.
Oh, you're back. Okay. Do you have any questions for the first two?
Nah.
All right, then let's explain the third one. I'm just gonna speed run through the 3, 4, 5, 6. Hannah, did you do 5, by the way?
No. I thought
Okay.
I was just doing 4.
Yeah, no, I know. Yeah, then in this case we'll just do 3 and 4, okay? Because there's pretty much similar techniques. So to the power of 6, this is 2x to the power of 6. And then minus, okay, Ryan, I think you missed this, okay? When you have a minus sign, okay, you want to alternate signs, okay? You can choose to write it out. Yeah, I think we'll just write it out in this case. So we'll plus 6 to x to the power 5, bracket minus 1, plus 15, to x to the power 3 minus 1 to the power 3. And make sure the power adds up to 6, okay? Plus 6 to x to the power of 1, negative 1 to the power of 5, plus negative 1 to the power of 6, okay? So we get 64x here, and we get a minus. The minus 1 just simply becomes a minus, right? And then we get 32 times 6, that's 190, something 192. And then here we have a -1 squared. So the -1 pretty much go away. It becomes a plus sign. The minus cancel out. Okay. So 15/8 is 120. I'm doing this on the sketch, so I might make some mistakes. Is this what everyone got?
Yeah.
Yeah. Is this question 3?
Yep.
Oh, yeah.
Okay. So a few things I would like to take note here. Apart from the number expansion and the multiply, the signs is alternating signs. Okay, we have alternating signs. Whenever we have a negative sign. Okay, and the reason behind it is pretty simple, because for the odd powers, including the first one, okay, we don't have the negative signs cancel out. Okay, all the negative signs cancel out. So -1 squared, -1 to the power 4, -1 6, they cancel out. So it's a plus. Oh, sorry, that's even powers. For the odd powers, they don't cancel out. -1 to the power of 1 to the power of 3, 5. They don't cancel out, and that's why they have this negative sign here. Okay. So the theorem is just still the same theorem, but when we try to generalize, we realize, oh, we have alternating signs. Does that make sense to everyone?
Yeah.
Okay. And let's try question 4. So yeah, 4x plus y. Okay. The power of what? 4. All right. So this is pretty much same. I'm just gonna rush through this without explaining too much. This is quite easy. All right, so this is pretty much how I would do this in the exam, writing down the 1, 4, 6, 4, 1, and just checking the powers. One is decreasing, one is increasing. And then we do the expansion, okay? All right, is this what everyone got?
Yeah.
I might make some mistakes here because I'm doing it on the spot. Ryan and Adriana?
Yeah.
Okay,
Good
cool.
enough.
Yeah, Ryan?
Mm,
Okay, so a quick note here. Wait, sorry, I think I made a, oh, I forgot to write a 3 here. Yeah, apart from that should be the same. A quick note here. This is no longer symmetric, okay? Because here, x and y are no longer interchangeable, okay? And we have this 4 in the front of x. That's why it's no longer symmetric. Only when I'm talking about the formula is it symmetric. Or when you have something like this, okay? This is only symmetric when x and y are interchangeable. For example, you have a plus b to the power of something, okay? Or when you have something like 2x plus 2y, right? When they are interchangeable, then the result must be symmetric. Otherwise, in this case, when you change x and y, they become different things, right? So it's not symmetric. So by that, what I mean is when you have, let's say, 2x plus y, right? If you change this to 2y plus x, they are two different things, okay? They are two different things. And this is when it's not symmetric. But if you have a plus b, and you have if you swap a plus b with b plus a, they are the same thing, and that's why the result expansion will be symmetric. Does that make sense to everyone? And by symmetric, I mean when you have an a4, you must have a b4, right? When you have like a 4a cubed b, you also have a 4b cubed a. Okay, that's what I mean by symmetric. Any questions?
No.
No. All right. What do you guys want to do? More theory or more practice? Oh, yes. Oh, very important. Oh, I almost forgot. There's a formula to calculate the coefficient when it gets too large. Okay, because you're not going to write down the Pascal triangle when you get up to like the 10th row, right? So you need the formula. And what is that formula? That formula comes from combination, but I'm not going to talk about the derivation of the formula. I'm just going to give it to you for now, okay? So let's say we have the Pascal triangle. Oh, before we do that, do you guys know what factorial is? If I have 3 factorial, do you guys know what this is?
3 plus 2 plus 1?
No. Anyone else?
Oh,
Anna?
3 times 2 plus times 1.
Times 2 times 3.
Yeah. So you multiply it down to 1, the 6. Okay, Adriana, do you get it?
Hey, that's what I said, mate.
No, you said plus at first.
Oh,
Yeah, you said plus at first, and then you said multiply.
mm-hmm.
Yeah. Adriana, do you get it?
Yeah, I didn't know what it was before, but I get it.
Okay, let's see. Let's examine you. Adriana, what is 5 factorial?
Is it 5 times 4 times 3 times 2 times 1?
Mm-hmm. What's the value?
1.
120.
Nice. All right. Ryan, what is 6 factorial?
6 times 5 times 4 times 3 times 2 times 1.
Yep. Don't use calculator. What's the value?
So, wait, can you write it out?
5 times 4 times 3 times 2 times 2 times 1 is already here.
720.
Yeah, 720. It is just 6 times factorial. Okay, 720. Hannah, what is 2 factorial?
2.
2. Okay. All right. Just I'm not gonna make you do 7 factorial.
Are you
unless
for real
want.
right now, bro?
I'm not gonna make her do 7 factorial. That's too much.
Bro literally gives me 6 factorial, and the next one is 2 factorial.
6 times 120. I could do that when I'm in primary school. I could do that when I'm in grade 2.
Hey. Okay.
Okay. Anyway, we got the Pascal triangle, right? And we have a formula called combination. Choose. Okay, we got n choose r. Hannah, can you tell me what this formula is?
It's wait, I kind of forgot. Is the n the
Big.
it goes in on top and it's like the factorial, like the full factorial, and then the r is the n minus whatever r is.
What's the formula? Do you remember?
N minus r factorial times r factorial.
Yeah, r factorial times n minus r factorial. The order doesn't matter that much. Okay, so that's the formula. Let's do an example. Okay. Before we do the example, let me ask you guys an intuition question. If you got 3 different outfits, how many ways are there to choose a outfit? That's very simple.
6.
No, choose one. You're choosing one. It's overly simple.
Wait.
You got 3 outfits. You're choosing one. How many ways are there to choose the outfit?
3.
Yeah, 3. All right, now let's say you got 5. Oh, not 5 too hard. You got 4 rings, and you want to have 1 ring on each hand. Okay.
Cool.
Okay, you know what? That's too hard. Let's say that's too irrational. Okay, let's say you're picking your food. You know those restaurants you can pick food, right? You got like all the different sort of food. You pick 2 with rice. Do you guys know those kind of Chinese restaurant? You got the rice and you pick 2 vegetables that come with it, right?
Mm-hmm.
So let's say the restaurant offer you 4 choices, but you pick 2. How many ways are there to pick the 2?
Eight.
No.
Wait, how many? What now?
4 choose 2.
2.
You're guessing. Let's say you got A, B, C, D, right?
Mm-hmm.
That's your 4 vegetable. You're choosing 2, right? You can choose A, B. You can choose A, D. You can choose A, C, right?
Yeah.
Or you can choose B,
4?
C. You can choose B, D, right?
Mm-hmm.
Or you can choose C, D. There are 6 ways.
Wait, but how would you work that out mathematically, like with maths?
That's why I started with a simple one, so you can
Oh.
work it out by counting. All right, mathematically is this n, right? N choose R. N choose R is N choose R. Okay.
Wait,
This-
what does that big C mean?
Sorry, the big C is a notation. This is the notation of that.
Mm.
This reads N choose R. Okay, or N combination R, or like combination N R, something like that. Okay. Adriana, you have been quiet for very long. Does this make sense?
Kind of. I don't really get the formula. Like,
Oh, it's okay. When you do it, you'll get it. All right, let's do an example. Let's do an example. Let's do 4 choose 2. Do you understand why? Okay, Adriana, do you understand why 4 choose 2 is 6?
well, I understood it when you drew it out, but
Oh,
like,
that's what I was asking. So when I drew it,
Oh, wait.
6, right?
I
yeah.
think I understand it now, Michael.
Sorry?
I think I understand it now.
Is that what, 6 or N choose R?
For 4 choose 2,
Oh yeah, it's equal 6.
mathematically. Because like you have 4 options and then you have 2
Okay.
choices.
Yeah.
And then if you look, you have 3, 2, 1. That's a factorial for 3.
Oh no, actually no, because it's just a coincidence.
Oh boy. Okay.
Okay? It's just a coincidence. Oh, but yes, that is actually true for all of them when you choose to. But that's only true when you choose 2.
Okay.
When you choose like 3, this no longer works out.
Okay.
But yes, when you have like A with everyone, that's 3, and B with everyone, that's 2, D, that's 1. 3 plus 2 plus 1. But that has nothing to do with factorial because that's plus, okay?
Yup.
But it is true when you choose 2. Let's say you got 10 choose 2. That is actually 9 plus 8 plus 10 plus 7 plus whatever, all the way to 1. But that's not factorial, okay? That's just how choose 2 works.
Okay.
But yes, good observation, good observation. That's correct for choosing 2. Anyway, back to the topic. I told you guys 4 choose 2 equals 6, and that works with the formula. So let's just try to work out 4 choose 2 using the formula. Okay, Hannah, what is 4 factorial here?
24.
Okay. Adriana, what is 2 factorial?
2.
All right, Ryan, what is 4 minus 2?
2 and then 2
What is
factorial.
so what is 4 minus 2
2.
factorial?
2.
All right, so this goes to 6, okay? And this number here actually represents something in the Pascal triangle. this number here is right here. 4 choose 2. Okay. In fact, I could label out every single one of them. So first of all, 1, 2, 1. Which this is a 2 choose 0, 2 choose 1, 2 choose 2. If you think about it, how many ways are there to pick one thing out of two things? 2. How many ways are there to pick two things out of two things? 1. There's only one way, and that is pick everything. And if we go down, we have 3 on the third row. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Let's just use an example. How many ways? Let's just look at this as an example. You're choosing 3 things out of, you're choosing one thing out of 3 things. 3 choose 1. There's 3 ways, right? We did it here. What about 2 things? It's also 3 because by choosing one thing, you're also neglecting 2 things. Okay? Let's say you choose one of them, and the other 2 is being left in the let's say choosing 3 outfit. The other 2 is being left in our room. So that's also the same as choosing 2. And that is why Pascal triangle is symmetric, in the sense of choosing 1 is also choosing n minus 1. Does that make sense to everyone? Any questions? If anything doesn't make sense, tell me. I can explain more.
Wait, could you explain that part again? Like,
Oh, okay. Before I explain the symmetry, does these numbers make sense when I mash them? Adriana?
yeah, did you just apply the formula to them?
Yes. I'm telling you the formula means, like, this is 4 choose 0, 4 choose 1, etc. And this is 4 choose 2, 4 choose 3, 4 choose 4. Okay?
Okay.
The symmetry I was talking about is, I was talking about, like, why, let's say 3 choose 1 equals 3 choose 2. So first of all, using the formula, this is all 3 factorial, 1 factorial, 2 factorial, and this is 3 factorial, 2 factorial, 1 factorial, okay? So formula-wise, they are the same, okay? We could generalize this even more. Let's say if we have n choose r, and n choose 1 minus r. Oh, sorry. N choose n minus r. Okay, maybe this is too complicated. Let's say n choose 1, and n choose n minus 1. They are the same. Because when you are picking that one thing, when you're choosing that one thing, you're also leaving n minus 1 thing behind. And we are looking at the total number of ways of combination. That's why they are the same. Does that make sense, Adriana?
Yeah.
If it doesn't make sense, just say no. Like, we can skip on this. Like, I just want you to be honest when I say it doesn't make sense.
It
So
kind of makes sense, but
Uh-huh.
like, it kind of does make sense.
So let's say you're choosing an outfit. You got 10 clothes, right?
Yeah.
Let's say you're choosing 2 clothes to wear. Okay, let's just speak hypothetical. Like, technically there's restrictions, right? You can't wear certain 2 at the same time. But let's just hypothetically speaking, you're choosing 2 clothes to wear. When you put the 2 clothes on, right, you got this one combination. But that one combination also corresponds to 8 that you are leaving behind. Okay. So in that specific scenario, you have 10 choose 2 ways to pick an outfit. And that is actually the same as 10 choose 8, because with every combination you choose, you're also leaving 8 behind, okay?
Yeah.
All right, anyone else has any questions? If not, we will, let's see if we have any combination question that we can do. There's a few really hard questions that we can go through together. But before we do that, I'm just gonna give you guys some binomial. I'm just gonna give you guys some combination questions to practice. Cool. All right. Let's just do a few, okay? 5 choose 2, 7 choose 3, 6 choose 5. Oh, you know what? This whiteboard looks ugly. I mean, the whiteboard is kind of just lagging on this computer. All right, this one's fine. Okay, sorry. We got, what do we have? 5 choose 2, 6 choose 3, 7 choose 4. Let's say 7 choose 3, 10 choose 2, 10 choose 3. All right, let's just do all of them, see what we get. In the meantime, I'm gonna write the formula here. All right, I think we'll do that for the last 10 minutes. Okay. There's definitely more to binomial, just more to the expansion. Hannah has done those before, but I don't think we'll get to those today. Yep. All right, technically you could just write out the Pascal triangle until the 10th row. But that's not the point of this question. So
There's no way you do that, bro. Like, I would actually die if I had to do that in an exam.
I reckon it'll be, in this case, it'll be faster. If you want to complete all 6 questions, it'll be faster if you do 10 row for you guys. Because you guys are not familiar with the formula, but I'm just saying that don't do it, so we actually get to practice.
Wait, do you want us to type it out?
If you're unsure, I can verify, but we'll go through them in the end. If you're unsure, type it to me. If you're sure, you don't have to. Adriana, that is correct. Nice. And bonus question. I think we have time for bonus question. Let's do 69. Choose.
Wow.
If I make this too hard, it's gonna be too hard.
No, make it hard.
Not
Make
make it easy. Make it slightly easier. 120. Choose 7. All right, guys, bear back to a minute. All right, sorry guys, choosing 7 is too large. I need to change the numbers. By the way, I just went to bathroom. Sorry about this, guys. It will only happen for today. It will not be every time. It's a coincidence. 120 choose. Let's say choose 4. More reasonable, I believe.
Wait, can we use our calculators for that? Or like,
Of course not.
what?
You
Oh,
mean the last one?
yeah.
For anything you can't. Oh, let's not do choose 4. Choose 4 is too hard. I'm gonna make it easier.
Wait, are we on? Oh,
60 choose 3. Oh, that's easier.
oh boy.
I don't want to make it too hard. Okay, that's fine. That's fine. All right. For the first 6, are you guys done?
Yep.
Yeah.
Hannah?
Yeah, sorry, it wasn't letting me unmute.
Okay, so if you're all done, we'll go through the answers first, and then we'll go through this. All right. First one. Anyone? What did you get?
10.
Okay. Anyone?
20,
Nice. Third one.
35,
All right. Fourth one.
40. Oh, wait.
35.
Sorry. What was it?
Well, I got 35.
Yep. All right, Adriana. Remember, 7 choose 4 equals 7
I
choose.
got that. I was reading the wrong one.
Okay. Remember, 7 choose 4 equals 7 choose 3. We can try to use the formula. You got 7 factorial over 3 factorial and 7 minus 4 factorial. Okay, this is 7 factorial. Oh, sorry, 7 minus 3. 7 factorial, 3 factorial, 4 factorial. And that is the same as 4 factorial and 7 minus 4. Right? The catch here is that look at the bottom numbers. They have to add up to 7. Okay? They always add up to 7. All right, what about 10 choose 2?
45.
Let's see. Yeah. What about 10 choose 3?
120.
Right, is that what you got?
Oh yeah.
Yeah,
was
because I
working
haven't
out,
done the calculations. I'm just comparing answers.
I was working out 60 choose 3.
Okay, okay. All right, now the final boss is here. We got 60 choose 3.
I got my answer ready already. I like had an epiphany, bro.
What did you get?
Nate.
Yeah. No calculator, no calculator. You can
Okay,
shout it out.
it's
I mean,
all right.
like,
I don't need calculator for, well, I kind of did, but you could do this without calculator anyways.
what do you mean you kind of did?
No, listen up, bro.
Okay, okay, yeah,
Listen
yeah.
up, bro. I got 34,220.
Okay, that is correct. Everyone else, try to give it an attempt. See if you can get the same number.
Nah, but I genuinely think the way I worked it out is like actually genius. Cause
There's a reason why I put this large number here, because there's a way to not grind out the numbers.
yeah, I didn't grind it out because I actually used my brain for once. So
Nice. If you are stuck, look at the look at the look at the hint I'm writing on the screen. All right, Hannah, Adriana, how are you two doing?
I did it. I use your hint.
Okay, nice. Hannah,
I'm done.
did you get the same answer?
How do I know if I got the same answer?
Oh, Ryan did shout out the answer, but it's okay if you didn't hear it. Yeah, all right, let's do it and let's see. So yes, 60 factorial does contain 57 factorial in it, right? It's 60 times 59 times 58 times 57, etc. So the 57 factorial essentially cancels out all the factors after 57. Does that make sense? So this gets canceled out. So you have 60 times 59 times 58 over 6. Is that what you guys got?
Mm-hmm.
Yeah.
Cool. And then you get pretty much 59 times 58 over 10 times 10, right? And the only calculation you have to do is 59 times 58. And it's a 59. We don't want to talk about this. It's too hard. So let's just do 60 times 58. Right? Instead of doing this multiplication, you can do 60 times 58 minus 58. You can do something like this, right? So by hand, this makes it easier. In that case, we get 58 times 6. That's a 348, right? 3480 minus 58 times 10. Okay? So we don't even have to use much of thinking at all. That's a 3422 times 10. Does this make sense to everyone?
Mm-hmm.
So when we see the 59, you can either just hardcore calculate it. That's kind of like a no-brainer as well. Or you can do something like this. You'd be like, oh, there's 59 58s. So let's make 60 58s, and we subtract 1. Does this make sense?
Yeah.
Cool. All right, I think that's it for today. Did you guys do the homework from last time?
Yes, I did.
Nice. Nice. Yes, I know Adriana did. Hannah and Ryan, did you guys do the homework?
I didn't even know there was homework, mate. I'm a bit.
Okay. In the group, check the group chat because I did send the homework in the group chat. Normally I don't leave homework, but last time log was something new. And this time is something new as well. So, but I'm not gonna leave homework for this because I don't have like a good practice worksheet for this. But for Adriana, did you complete everything from last time?
Yeah.
Like the homework, did you do 100%?
I don't know, but I did it. Like, I
Okay.
did things.
So finish off what you haven't finished. If you finished everything, then there's no homework for this week. But for Adriana and no, sorry, for Ryan and Hannah, you guys can do the homework from last time. Okay.
Yeah.
Yeah.
There's a page of log questions. Yeah.
Mm-hmm.
Yeah. Any questions?
Nope.
All right. In that case, that is it.
Okay.
I'll send the notes in the group chat shortly, and I'll see you guys same times next week, but maybe during this week as well.
Okay.
Yeah.
Thank you. Bye-bye.
Adriana, do we have a lesson on Monday?
Yeah.
All right. See ya, Ryan.
Thank you. Bye.
Thank you. Bye.
Okay. See ya.